video is a continuation of the topic on how to graph the quadratic function and identify the following: A. Axis of symmetry, B. Vertex, C. Intercepts, and D. Domain and range. For step 1, identify the axis of symmetry. So from the given quadratic function y equals x squared minus 4x plus 5, first we are going to identify the value for a. A is 1 and b is negative 4. So we are going to solve for the vertex hk. So from the formula, h equals negative b over 2a. So b is negative 4 over 2 times a is 1. Negative times negative 4 is positive 4 over 2 times 1 is 2. So 4 over 2 is 2. So the value for h equals 2. For step 2, identify the vertex hk. Since h equals 2, we can plug in the value of h to the function and solve for k. So let's write here k equals f of h x squared minus 4x plus 5 so we will replace h with 2. So this is 2 squared minus 4 times 2 plus 5 f of 2. 2 squared is 4. Negative 4 times 2 is negative 8 plus 5. So the value for k is positive 1. So our vertex hk is 2, 1. For step 3, determine the opening of the parabola. Since a is equal to positive 1, then the parabola opens upward. And for step 4, make a table of values of at least 2 points on the left and 2 points to the right. So we will write here 1 and 0, then 3 and 4. Then we will write here the given quadratic function x squared minus 4x plus 5. Then we will use 0. This is squared minus 4 times 0 plus 5, and the result is 5. And using 1 minus 4 times 1, plus 5 equals 2. Then we will replace x with 2 minus 4 times 2 plus 5 is equal to 1. And we will replace x with 3 minus 4 times 3 plus 5. This is equal to 2. And when we replace x with 4, this is 4 squared minus 4 times 4 plus 5, and this is equal to 5. So we have here 0 and the output is 5. When we use 1, the output is 2. And then when we use 3, the output is 2. And when we use 4, the output is 5. So we have here the points 0, 5, 1, 2, 2, 1, 3, 2, and 4, 5. For step 5, determine the intercept of the function. To solve for x-intercept, we replace y equals 0. So y equals x squared minus 4x plus 5. Then we replace y with 0. Then we are going to use the quadratic formula, where a equals 1, b equals negative 4, and c equals positive 5. So using the quadratic formula, the result of the radicand has a negative sign. So based on the results, when the radicand is negative, the roots are imaginary and the graph doesn't pass through the x-axis at any point. So there's no x-intercept. And to solve for y-intercept, we replace x with 0. So we will write here the given quadratic function y equals x squared minus 4x plus 5. So we will replace x with 0 plus 5. So y is 5. So the y-intercept is 0, comma 5. So this is our y-intercept. And for step 6, plot and connect the points from the table to form a parabola. So we have here the points 0, 5, 1 and 2, 2 and 1, 3 and 2, then 4 and 5. So 0 and 5, so we will locate 0 and 5, positive 5. So this is 0 and 5. Then 1 and 2. 1 to the right, and 2 up. Then 2 and 1. 2 to the right and 1 up. Then 3, 2. 3 to the right and 2 up. So this is the point. And then 4 to the right and 5 up. 4 to the right and 5 up. Then we will connect the points. So this is the parabola. It is going up. Parabola is going up because A is positive. And this is the axis of symmetry. Axis of symmetry. And the equation is x equals 2. And 2 is the x coordinate of the vertex. So this is the vertex. So the x coordinate is 2. And that is the axis of symmetry. And for domain, it's negative infinity to positive infinity. And this is always the answer for any problem in quadratic function. So for the range, y, so the parabola is going upward, so the sign is greater than or equal to 1, and 1 is the y coordinate of the vertex. So thank you very much, and I'll see you in my next video.